Hello, our most developed student. My name is Confident and welcome to our revision session. And in today's lesson, I want to focus just looking at some trigonometric formulas. So time and again, you find that students, they get confused when they come to the trigonometric formulas, and I thought of bringing this lesson to you. And the main part here, it says important basics you must not forget. So it says important basics you must not forget, but it's when you are dealing with trigonometry formulas. So what I will encourage you guys as you are going through this lesson, first things first, remember to subscribe to our channel, as well as ensure that the notification bell is turned on so that you can be notified every time we are posting a new video. So let's look at this lesson here. First things first, as I said, let's look at some trig ratios. So when we are dealing with trig ratios, one thing that must come into your mind whenever you look at the word trig ratios, the first part is, what are we dealing with? So when we're dealing with the trig ratio, we are looking at a right-angled triangle. So that's the first thing you must know. You need to know, or you need to remember, a trig ratio only is applicable to a right-angled triangle, and a right-angled triangle is a triangle with a 90 degrees angle. So that is a right-angled triangle, and in this particular right-angled triangle, we apply what we call SOHCAHTOA. So when you're talking about trig ratios, we are talking about SOHCAHTOA. As I said, this is a right-angled triangle, and when we are talking of a right-angled triangle, you need to know how to label this triangle. And to label this triangle, the first part is identify an angle on the triangle. And once you identify the angle theta, then you can now label it to say the longest side is your hypotenuse. So that's the longest side. And when you have a 90 degrees and an angle, we call the side the adjacent. And when the other side automatically becomes what we call the opposite side. So these are the three sides of a triangle which you definitely need to know. So now, how do you write the SOHCAHTOA? Now the word SOHCAHTOA means sine theta is equal to opposite, which is op, over hypotenuse, which is hyp. So that is the first trig ratio you must know. So whenever you're writing it, you can say sine is equal to O over H, meaning opposite over hypotenuse. Similarly, C stands for cos. Cos is equal to A, which is adjacent over hypotenuse, as well as tan is equal to opposite over adjacent. So let me write that again to say cos theta is equal to adjacent over hypotenuse. I'm just writing it in brief, as well as tan theta is equal to O stands for opposite over A stands for adjacent. So now you need to know these trig ratios. As I said, the easier way to remember is the word SOHCAHTOA, which says sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite of adjacent. Some use the word, let me see if it's correct, it's SHASHOTAYO. Let me try that word. It's SHASHOTAYO. Let me use it's SHASHOTAYO. Let me see if ever this is working. Is it SHASHOTAYO? And then SHASHOTAYO. Let me try this one. It's am I right? SHASHO. Yes, I think this is the word. Some they use SHASHOTAYO, but I think this one you read it in this direction. To say shashotayo, what does it say? It says cos theta is equal to, and then you read it in that direction. A means adjacent over hypotenuse, and then sine theta is equal to opposite over hypotenuse, and tan theta is equal to op. See that it matches over hypotenuse. So this is the when you're reading it from right to left, but the normal one is the one which is SOHCAHTOA. You are reading it from left to right. So these are the important trig ratios, and with these trig ratios you get the formulas for sine, for cos, as well as the formula for tan. So that is the first one. The next one is the inverses of these trig ratios. Now what are the inverses? If you are given sine, now the inverse for sine is cosec. Okay, and then what about for cos? The inverse for cos is sec. And what about for tan? The inverse for tan is cot. Alright, so now you need to know now the formulas for the formulas for this. Now remember, we said sine theta, remember SOHCAHTOA, you have got SOHCAHTOA, but let me make it as a single word here, SOHCAHTOA. We said it's SOHCAHTOA. Remember, we said for SOHCAHTOA, sine theta is opposite over hypotenuse. So that you don't forget, you must put just division lines like that, so it can also help you not to forget. And then what about for, in this case, for cos? Cos theta is equal to adjacent, which is that over hypotenuse, and then we will have tan theta, which will be equal to opposite over adjacent. So these we just dealt with previously. Now let's look at the inverses of these. Now the inverse, as I said, sine means cosec. So here, if I'm saying you have got sine, and sine is linked to cosec, right? Now cosec, when you're talking about the inverse, means hypotenuse over opposite. So that's the formula for finding cosec. What about for cos? It becomes sec. It will be theta there, sec theta. You also invert that, which becomes hypotenuse over adjacent, and also tan becomes cot theta is equal to adjacent over opposite. So this is that. And also something to note whenever you are dealing with these inverses, it is to note when I say to you what is cosec theta, you must know that it is 1 over sine theta. Are you with me? So even if I say what is sine theta, you must know that it is 1 over cosec theta. Hence we call them the inverses. Similarly, when I say what is sec theta, you must know sec is linked to cos, so it becomes 1 over cos theta. And then what is cot theta? It becomes 1 over tan theta. So these are the inverses that are very, very important for you to know. Now let's continue again looking at the most important formulas in trigonometry. Now this one says 2 most common trig identities. So these are very common trig identities. The first one that you need to know, I emphasize this one, is tan theta is equal to, what is tan theta? Actually is equal to sine theta over cos theta. This is a trig identity that you need not to forget. As I said, these are the most, this one saying two most common trig identities. The first one is tan theta is equal to what? Sine theta over cos theta. Always remember that. Tan theta is equal to cos theta over sine theta. And I also say to you, sometimes they can give you to say, what about cot theta? So if you can know tan, you know cot. Cot, remember, is the inverse. You take that to the top, you take this to the bottom. So cot theta is same as saying cos theta over sine theta. Are you with me? But this is not the common one. You just use that one to do. So the first one is that. So don't forget, tan theta is equal to what? Tan theta is equal to sine theta over cos theta. The second one that is very, very important for you, number 2, is the identity. I hope you're remembering it, which says what? Sine squared theta plus cos squared theta. This is equal to what? It is equal to 1. A very, very, very important and common trig identity. You cannot be in a position to prove any trig identities if you are not familiar with these two trig identities. Now, I just want to focus on this number 2 because there are a few things that I want you to take note of. Now, this identity can be written in actually, I can say in 3 or 4 different ways. The first one is they can take this part, cos squared, to the other side. So it will become what? That is, I'll call it 2.1. 2.1 will be, you are left with sine squared. It will be sine squared theta is equal to 1 minus, remember it was positive, when it jumps the equal sign, it becomes negative. So it's 1 minus cos squared theta. Right, that's the first one. Always remember that. Now, you can be given 2.2, which in this case, instead of cos, it will be sine crossing the equal sign. When sine is crossing the equal sign, you'll be left with cos squared theta. On your left hand side, it becomes 1 minus sine squared theta. That is another version of that. Very, very important. Now, let's take this further. If I have, for example, this one. Now, sine squared, I can further write it as saying sine squared theta is equal to, now to take it further, remember 1 is same as 1 squared minus cos squared theta. Are you with me? Now, if you do that, this becomes then a difference of 2 squares, which is 1 minus cos theta and 1 plus cos theta. They can play around very, very much on that one. Similarly, if you are looking at this one, so it will become, you open bracket, which is 1 minus sine theta and what? 1 plus sine theta. So very important. So when they give you 1 minus sine theta, 1 plus sine theta, you must know that this is actually the same as sine squared theta plus cos squared theta is equal to 1. Just be able to see that. If they give you that, if they give you that, if they give you that, if they give you that. So you see, there are 4 ways you can actually rewrite that. So this is an important identity. And don't forget the first one to say tan theta is equal to sine theta over cos theta. But not much to say. Sometimes they can give you this one whereby they cross multiply over 1. When they cross multiply like that, you must know then to say in this scenario, what is sine theta times 1, which is sine theta, is equal to tan theta dot cos theta. See, this is another way you can actually even write that, but it's not a common one. Don't forget, these are ways of representing this trigonometric identity. A few things again. Area of a triangle, very, very important. So there are two areas of a triangle that is common. The first one is when it's a right angle triangle. This does not involve any trig. This formula here is area A is equal to half base times height. Very standard, but I'm not dealing with that. So it's a standard formula, but here the triangle that we're dealing with is a non-right angle triangle. For example, if I'm given a triangle like this, and I need to find the area of this triangle, and this triangle is A, B, and C. So if I want to find the area of this triangle, what you need to do is to identify two sides, which is that side, for example, this is an example, and that side. Suppose I'm given these two sides. So if I'm given these two sides, remember how you label it? You label it to say from C, this becomes small c. From A, this becomes small a. From B, this becomes small b. So there is side B, side A, side C. So if I have, in this case, let me take out these arrows to say, we say this is my C, this is my B, this is my A. And my lines here, remember these lines, they are forming an angle at B. Do you see that? So if they are forming an angle at B, let's mark that angle there to say there is an angle at B. So when you are writing now the formula of this particular triangle, you are going to say area is equal to half. Now you look at those two lines, you see I've got A and C in alphabetical order. It's half AC, and then you say sine the angle there is B. That is how you use that to find the formula of a triangle. So I can use another set of lines. For example, I can use this line and this line, and I will have this angle here. So if I'm going to write the area now of this triangle to be area is equal to half. Now my two lines is A and B, so it will be A, B. Now it will be sine C. Do you see that? So it depends which lines are you dealing with. So that is the other way. Or what if I choose, in this case, I choose two lines, this one in red, forming an angle at A. See that? So if I choose that as my angle, so what will be the area? The area here will be area, I think you can see it now, is equal to half. You can see B and C are the ones that are forming the angle. So it will be B, C, and then sine the angle there is A. So when you mention the letter B and C, is the angle of that other unknown letter. You see, if I say AB, the angle is C. AC, the angle is B. So that is the area of a triangle. And then let's look at the sine rule, a very also important formula. What is the sine rule? It says when you are given a triangle also like this one. So this is a triangle, and we're going to call it triangle A, B, and C. Now remember what I said, A becomes side A, B becomes side B, and C becomes side C. So these are the angles. It says when you're given that formula, sine A as the angle over side A is equal to sine B, that is angle B, over side B, which is equal to sine angle C over side C. Or you can rewrite it, it's also allowed to write it like this, that with side A over sine A is equal to B over sine B, which is equal to C over sine C. These two formulas mean the same thing. You can write it in the first one or in the second one, is still the same. So that is the sine rule. When you know the sine rule, you also need to know the cosine rule. So also with the cosine rule, what you are given is, if I have a triangle like this one, for the cosine rule, and my triangle is also A, B, and C. And don't forget how you label it. This is my small a, my small c, and my small b. Let's say I have got that angle being marked, right? So what does it say? The moment I mark that angle, I've got my side b there. So I'll write it as b squared is equal to a squared, which is not the side that I didn't have there. The other side that I don't have there is c squared. So it's a squared plus c squared minus 2ac cos the angle that I marked there as b. If you focus on this angle a, right, you must also consider side a. So you start by saying a squared is equal to b squared plus c squared minus 2bc, and then cos becomes cos a. So also, if you consider this side c, it will be what? C squared is equal to a squared plus b squared minus 2ab cos c. So this is the cosine rule in FOA. And then now extended trig identities. Now I'm extending this one. Sometimes it's not a common one. Now with these extended trig identities, what I have, I'll be having cos 2a here equal to, and then I come up with three different versions of cos 2a. The first one is cos squared theta minus sine squared theta. The second one is 2 cos squared theta minus 1, and the last one is 1 minus 2 sine squared theta. Very, 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 very important. Now, sometimes you can extend this further because that's what they ask. This, remember, becomes a difference of two squares here. Let me make it like this to say this is a difference of two squares. You need to be very sensitive with it. So it will be cos theta minus sine theta, and the other one is cos theta plus sine theta. Are you with me? So similarly, this is a difference. No, this is not a difference of two squares, so it's done. And then the last one that you can do, or that you need to know, is if you're given cos 2a, what about sine 2a? Remember, sine 2a is 2 sine a cos a. So these are extended in a way, but they are very, very important. So guys, we've come to the end of our lesson. I was just giving you basic trigonometric formulas that you need to know as you approach your grade 11 and your grade 12. I hope this is of help to you. Remember to subscribe. Remember to press on the notification bell so that you can be notified every time there's a new video. Thank you.